of research student in Macquarie University. So currently I'm working in sustainable construction material. So this is my part of my study. So today I'm going to present eco-friendly alternatives as the replacement in concrete. So our first question is what's the concrete? So concrete is basically a mixture of water, fine aggregate, cement, and coarse aggregate. And it's a hugely used material. And due to global urbanization, economic development, and the growth of population, the demand on concrete is increasing day by day. It's more than 10 million of tons of concrete produced everywhere, and it's the most consumed material after water in the world. So over 70% of all population living in the concrete. So because of its versatile use, workability, strength, durability, longevity, and fire resistance, it's the most usable material in our part. But apart from this, this is also a harmful material for our environment. There are lots of problems associated with the concrete. Like if you say more than 5% of carbon dioxide production, greenhouse gas, it comes from the concrete in all over the world. So we need to do something here so that we can reduce the impact of carbon dioxide. So we are thinking about the use of the raw materials, energy consumption, and water use, reduce them, and use something waste material or byproducts material which are abundant in our environment. It comes from the industrial products, so that we can reduce the impact of the concrete. But if you can see here in the graph, the cement production rate is increasing day by day. And in the cement production system, we are using a high heat system with really consumption a lots of energy, and it uses a huge water, and it generates a lots of amount of waste. So for doing this, my study, it will basically how can you reduce this carbon dioxide and use some industrial byproducts or domestic waste kind of things. So for the make the concrete eco-friendly, our main focus is on using recycling and using waste material. If you look in the Australia condition, it's more than 40% Australian waste goes to the landfill without doing anything. So I define in the three waste materials like industrial byproduct, commercial, mining, and agriculture operation. It comes from the fly ash, bottom ash, and steel slag. And besides this, we have domestic waste. It comes like a glass, plastic bag, packaging, and it comes through the cleaning, cooking, and repairing empty containers. Even if you overlook here, lots of construction and demolition work is going on in our side. So it also comes with lots of wood, steel, concrete, and plaster, this kind of things we can really implement in our concrete productions and in our manufacture system. In the photo, you can see how all like landfill productions and here everything is abundant in the field. So in my first study, I focused on the fly ash, and I really found a good result in here. It's totally abundant from the coal burning power plants, and sometimes it's known as Airspeed. And after studying this, I found that it can reduce around like a 20% of cement consumption, and which can really help in to get a better concrete and better environment impact. And even it can, after using the fly ash, I even found it is reduced the amount of water used by 10%. Even using fly ash in the concrete, we can see that it reduced the bleeding. Even it has a very high level of strength, increased amount of strength. But sometimes in the fly ash, this problem is this wide variety of chemical composition is really help to reduce the how its products is coming. So it's really very vulnerable. Besides that, we have bottom ash, which is also a power plant product and is really goes to the landfill. But after using the bottom ash in the concrete, it really helps to increase the workability, settings time, and strength. And it can be a good substitute beside of cement. Even for another industrial product, which is the rice producing country, in rice husk and rice mill, and by replacing it, we can use a 20% of the strength gain in concrete. And to get the optimal, this one can be 20%, and it can be replaced 15% of cement in concrete. We have another industrial product that is silica. In my studies, it can replace like a 7 to 12% of cement, and it is a very high strength and it can be durable. Sometimes it's known as micro silica, and it comes from the silicon metal producing manufacturing industry. We have another industrial product that is blast furnace slag, but it has a very good result in than others. It can replace around 70 to 80% of cement, and it has a very improved workability. And in long term, this is a very high strain in compressive and flexural strengths. So I was studying about this ceramic waste powder as well. It's like a unutilized domestic waste. So it's produced a huge amount and in final polishing system in industry. So it causes a lot of pollution in the soil, water, and air. So, but it has a good improved workability in concrete mixtures, and it can reduce the compressive strength and development required time, but it can improve the durability characteristics of concrete. So on my another study focus on the waste art, and this is the most challenging and problematic waste stream in condition of health and environment concern, but it poses a good breeding system for pests, and it's a significant fire hazard as well. So by using the waste art as a crumb rubber as an aggregate, and we can use as a cement replacement as a rubber powder as well. And although it has some reduction in the flexural strength, but it increases the tensile strength as well. So basically, our lots of studies going on here. Even in Victoria, is implemented in the road as well. So currently, I'm studying on here as a life cycle assessment. So my result hasn't got. So another, lately I was focused on the construction and demolition waste. It's the wood ash. So in like construction and demolition, we got a lot of wood, which is, but if we wish, we can use this one as a partial replacement of cement. And you can see here in that it gets a really high compressive strength. And I was thinking to use as a cement powder as a in concrete. It is recyclable, and it is a really good strength. Even we got as the same similar kind of result and as a cement powder. So my conclusion goes through here. We need to reduce the amount of Portland cement so that we can use a lots of supplementary materials. So can we use a lessened amount of cement, and you can lessen the amount of raw material, and we can use more highly recyclable material in it. If anyone interested to collaborate with me, please contact, and this is my mail address. Thank you. If you have any questions.
Thank you, Habiba. That was really great. Oh, sorry. Go ahead.
Yeah, so thanks, Janice. Thanks, Habiba, for presenting this paper. It's pretty cool. Can I have a question regarding the wood ash? How we can use it as a supplementary material, or you can say supplementary cementitious material? I think the wood ash, it's almost the one is in, yeah, and the last one, 14 or 13, yeah.
It's basically like construction and demolition waste, the wood. So we can, this recycling process, we can make it the ash, like after burning, I think. We can use the wood as a burning in cement, and we are getting that ash. I think from that ash, we can use it.
So basically, it's like a grinding or like
as a energy, it's like a fuel, and after that we'll use that ash as a replacement of cement.
Yeah, but have you got this one from any reference? I mean, do you have any reference for this one, this slide, wood ash?
I didn't really add it here.
Okay, so it's not in the number 16, if you go to the slide number 16, maybe.
Yeah, no, it's not there.
No, okay. Yeah. Because we should know whether how like a wood will be like reacting with the cementitious material. I'm not quite familiar with this one. So yeah, anyway, nice presentation. It was nice brainstorming for supplementary cementitious material. Thank you.
I have a question. So these are like industry waste products. Are they already being collected, or is it something that you're experimenting on for the future uses of, I guess, being in a more circular economy where we can use these?
Implemented, and it's already implemented and already being used. I'm working in like environment impact analysis. I'm just implementing that material, how we can be environmentally benefited, or like how much is the benefit in the reduction of the carbon dioxide.
Oh, okay. So it's already being implemented, but
Yeah, it's
you're
already being
finding, I guess, like the statistical.
Yeah.
Okay, I understand. Thank you very much. Are there any more questions today?
Can I ask one? Okay. Thanks a lot, Habiba. I guess there were a comparison between a few supplementary cementitious materials being fly ash, wood ash, and slag. I've never tried that in a laboratory, and I wanted to ask you whether there is a comparison between the compressive strength gained when each individual of these SCMs, supplementary cementitious materials, are mixed in concrete.
Actually, this is basically my literature like study. I'm working on the carbon dioxide reduction system. I'm working in life cycle assessment.
I see.
So I just study on it. This is how much it can be benefited us, and I got this result, and I am implementing in the life cycle assessment. So I didn't really carry out this experiment.
Okay, is there any like quantitative comparison between these in terms of CO2 reduction?
That's what I wanna do. I gonna mix up I gonna make lots of like a computer mix, and then I will see the which in like material is giving the more beneficial result in it to reduction the carbon dioxide.
Okay.
So I haven't got my results yet.
Okay.
Mm.
Thanks a lot.
Thank you.
Really informative.